Okay, guys, misleading data. Okay, it says misleading data displays. The way a data display is drawn can lead people to make incorrect conclusions. 3 examples of potentially misleading data displays are shown below. Now they're not incorrect, but they can be misleading if you're not careful, if you're not focused on what you're looking at. Okay, let's look at this first one. This one says broken vertical axis. The broken vertical axis exaggerates the differences in the bar lengths. Okay, so if you look at this one, the difference between here and here is 160. But if you don't notice that it's broken, then you might imagine that that's only 10. Or that this should also be the difference of 160, so it should be 320. And this one should be 480 and 640. Right? If this unit right here is 160, why aren't all the others? And here's the result of that. Okay? When you're just looking at the bar itself, this bar looks almost 4 times the size of that bar. Okay? But if you look at it, this bar represents 160 and this one's about 187. Not 4 times 160. Okay? So you can see how that can be misleading if you're not careful when you're reading it. Now, when you look at the next one, large increments, it says the large increments on a vertical axis minimize the changes in the data. So I don't really, this doesn't look like a big change, but that's a change of about 300 between those 2 dots, between those 2 data points. This doesn't look like a lot of change, but it's really about 600. Okay? So you can see how if these units jump a lot in large increments like that, it minimizes the amount of change that we can see. All right? And then the last one here is just absurd, really, but you do see it occasionally. The different bar widths suggest a comparison of areas, not lengths. So you see how when you look at April, you think, man, look how big that is, right? And look how tiny this thing is, when really it's 12 and this is 30. Okay? Making this bar on the right for April fatter makes it seem even bigger than the one in January. Okay? Yeah, Max.
Can you explain me how it goes from 0 to 60?
0 to 160. What they've done is they basically took a big graph, right, from 0 up to almost 200, and they said, you know what, we want to cut this thing in half, right? We don't want all that because our smallest number is 160, way up here. So we don't need all of this space. So we're just going to draw our graph up here, and we'll just say this is 0. We'll let this be 0, right? And we'll break this right there, like we just shrunk it because we don't need all that space. But you see what happens is it makes the differences exaggerated. One looks a lot bigger than the other. So let's look at example number 3 quickly before we run out of time. Number 3 says, the line graph displays a company's expenses and profits for each year from 2000 to 2003. What is misleading about each one? Now this is the same data in each graph, right? But what is so misleading about A? What do you think about that one, Will? It's in large increments. I can't really tell. It doesn't, it looks like their profits are going up some, right? But it went from, this is in thousands, from 200,000 to 300, maybe 10,000, 320,000. That's a big change in profits. Okay, that's more than 50%. If you look at B, what's so misleading about B, Ruben? I'm sorry? Looking at this graph, what is it that makes this graph misleading? Well, they are kind of different increments, but what makes that true, Reed? It's a broken vertical axis. So from here to here is 210, and then from here to here is only 10, right? So it exaggerates the change in the profits. Okay, so it looks like the profits went up almost 200%. Okay, all right, guys, you did a great job. You ready for your homework? See ya.